Okay. DNS is simple domain name resolution system or domain name resolution server. So it's easier for people to remember names than remember numbers. It's the other way for some other people, especially people that did something on tactical mathematics or something. But for majority of people, it's easier for them to remember names than for them to remember numbers, especially the one with dots in them, dash and stuff. They just prefer to just call it a name and remember the name. So how this works is, so for example, you're trying to access Google. What does Google do? Or what does your system do to even get there in the first place? Your system says, okay, once it sees Google, it's looking for what IP address is that tied to, or what should I be looking out for? What address is that tied to? What should I be looking out for? Let's even do a simple example now. Let's try and ping from your own system. Try and ping Google. Let me just stop sharing that. Let me screen share again and share everything. Share. Hmm? Let's see if you see whiteboard here. Security annotation. Okay. Okay. So yeah. So let's just do a simple test. Let's say CMD. And try and ping Google. You see, it will. Oh, not Google. See, you say it does not know what Google is. But if I book .google.com, you say, oh yeah, I know what this is. Because Google don't mean anything to the system. You can't reach it. But when I put google.com, it quickly says, oh yeah, I have an IP address for that. How does it even get an IP address? How does it know there's an IP address for that? So that's what I was trying to explain with the diagram I was drawing just now. How do I now get there? You can see what you share here. Record it down. Why is it not? Okay, I have to go back and share that. That's not right. Okay. What is, does it saying I can? Oh, don't mind. I've not. You don't use this thing too often, so I wouldn't know. Okay, that's fine. So this is the wrong page then. Maybe I should just go to a plain page. Do I get that plain page up? Okay, let me not even use this one. Let me just close this one and use my own whiteboard. It's just that my whiteboard is quite heavy, so it takes a while for things to get cleared. Share link. No. Go back. It's a new one. Alright. So we have this guy here. And we have, let's just call that a router. And we have the internet here. And we have, this is you and me trying to access internet. And this is, just call that a router. And this is here. And our connection is going to a good router, and the good router somehow gets connection to the internet. So there are several other hubs here. that the system have to go through, but that really don't put that also. I'm just using your home network as an example. So when I type that google.com, so what it does immediately is, first of all, it goes and searches the router. What's your, because these things are already, they have in a place where they've saved, there's a name resolution service where all that name that you have is tied against IPs. There's a place like that on this particular router, and says any IP you see with this stuff, this is what is called. If you hear google.com, this is what IPs you should use. If you hear that.com, this is the IPs you should use. But its own name on its own name resolution server. So that resolution server might not necessarily be on the router. It might be on the back end, maybe somewhere of the service provider that is trying to do that management. So the internet service provider, call them the ISP, they might have that server which they've put the IP address on this router, says if you have any of such, just throw it back to us. We'll be able to tell you what IPs to use to reach the name that you are trying to call. So all that IPs are registered somewhere. So that is how your system knows that, oh, there's an IP address for google.com, but there's no IP address for just Google. Then then from there it goes to the internet, pulls the information out, and all these things are done in split seconds. Okay, so why I brought this stuff out was to use this particular one to explain to you how it works. Options. Okay, with that, options. I don't like doing this. I just prefer to use this. Hope we still can see my screen, so that's fine. So the computer goes to the DNS resolver, so I can then use my annotation here. So that's the first step. It goes to the DNS resolver, which I told you is that IP address that the service provider have somewhere that has a list of all those IPs that it goes to. Then it has a root server, and it has a TLD server. I don't know what that TLD is just now. I don't know what it is. Well, I don't know what the root server is. Maybe that's one of those sub servers that's connected to the DNS resolver. And then traffic goes to the root server, comes back from the root server, goes to the TLD server. Then it comes to the authoritative server. Then authoritative server sends that information back and forth to confirm that on the website, as on the internet, that IP to that name is okay to be used. Then the authoritative server then sends that information back to the computer, that the computer has to use that information. So this is more like a logical way it works. So all these processes will have to go through your service provider before it actually gets to you. Okay. I know it's still very complex just now. Just give me 1 minute, 1 more minute. It will be broken down. So for this one, annotation, is it? Okay. This one should be 321. Good. So this is the stub resolver, and this is the recursive resolver. Just don't mind their names. This is the authoritative server, and this is the authoritative server. So authoritative server is more like the server that determines or where that information of that DNS actually lies. So for your level, let me not go too deep into it. For your level, just understand that DNS is just a server that resolves names to IP. If you can remember that, and then remember that when it's doing its resolution, it goes through a series of steps like we explained just now, from yourself to your um, root domain name server. From that root domain name server, it goes to somehow to get to the authoritative server on the internet. The authoritative server now responds back after confirming that that information is true, now responds back to you with the information that that name represents. Do you understand what I've just said? Okay, that's you here. Oh, let me use annotation again. Oops, getting helpful and useful. Okay, let's say this is you here. That's your root domain name server, and that's the authoritative server that you need to use to get but you should get used to the name. This one is they call this one recursive resolver. I will not use that recursive. I just prefer to use the root DNS server. It just makes life easier for me. Then I can then remember the authoritative server, because that authoritative server, there's no other name you can give to it. So on the internet, that's the one that maybe used by the service provider or whoever is using it. That's the one that understands which names are assigned to all public IPs. So that now sends back an information to me, to my recursive server. My recursive server then sends the information that I'm requesting for back to me. Who is the requester? They call it here stub resolver. Okay, so that's DNS in a nutshell. Is there any question? Do anybody not understand what DNS does now? Is there anything that's still not clear? Okay, I guess not. I guess everybody's happy. Good. So if you want to get a better understanding of DNS, again, you can just, so that's DNS server there. So that's the real website. Somebody can obfuscate your systems. Yeah, that's DNS snooping. It's a different thing entirely. Okay, so try and get to maybe YouTube or something and find out what DNS is if you are still not very clear. But in simple terms, it's what helps you to resolve names to IPs, and what helps you also when you want to find the IP address of a name of a particular, or when you want to find the IP address of a particular name. For example, Google now. If I want to find the IP address of Google, I just ping google.com. I now know that IP address. Another way to do that is just do ns lookup. ns lookup. This one is more like a function on your system that can help you look up the DNS, any DNS, and see what IP address is tied to them. So in this case now we are still using Google, right? Google.com. Now it's giving me a different IP. Earlier on we saw one IP, now it's giving me a different IP. Now if I wanted to give me all the different it's not showing me. If you wanted to give me all the different IPs I can possibly use, right? It should have just shown me everything. I think there's an extra command I needed to use. Let me try flat D. Okay. So no, that one is just giving me full information as to what it's doing, how long. Okay. So you can find out the different what was it called from your own system now. You can do NS lookup, then find out the different what they call it. Is it key they call it? Different keywords, not keyword. I know this thing very well now. Okay. The different this dash something is called something, it's not called keyword. Flag. Well, different flags. I'm still trying to find the right word. So this you can also call it flag. These are different flags or extensions, but there's one that can give you all the different IPs that are tied to this particular google.com. Let me try flag A and flag T. That one doesn't do anything much. See, the IP address have changed again to 142 from 147. Name is this. Let's change to that. So flag T. That's changed again to that. So it's dancing between this and that.
Why did the IP addresses change?
Because different IPs are tied to it. So you know how many people are trying to find out something on Google just now, or trying to reach google.com just now. Maybe a million people at the same time. So they need to put different IPs there. There's so much one IP can take. Remember, okay, if you're in the NAT class, I told you if you're doing private NAT overload, that an IP address can take so much. So you might need more than just one IP address to handle. That's why we need dynamic NATing to handle more IPs. But this one is DNS. It's different. So DNS will help you to leverage on that ability that a system would need to have. So this is more like on a bigger scale now. You want, just in case like a million people are trying to hit a particular URL, that some people don't get delayed or disconnected. Everybody still gets a connection. So you just want like 3 or 4 IPs to be behind that name. So whatever anybody's requesting is resolving, and we have enough servers behind the scene doing the same thing that can respond to whoever is asking per time.
All right.
All right, so that's it for today. Gotten to the end of the class, so please do some of your own research too on DNS. In fact, let me give you as an assignment. Just draw a simple diagram of a DNS. Don't come and copy any of these things to me. Go find out what is DNS, and then in your own layman's term, find out how to explain it. And the explanation I need is you trying to access something on the internet. How many stages will you have to go through? What are you going to check? What needs to be checked before it gets to you? So be a bit more detailed than what I just did now. So if you can do that and come back to me with one single slide as to what DNS means to you, it's it will help me know whether you really understand it or not. Because that's one big interview question that you will get. They don't just expect you to answer that, hey, DNS means resolving names to IP. That's not what they really want. They want to understand the process of how that even actually works. What are the things in play? What makes that resolution possible? All right, that's it for me today.